So what our packet's about that we're looking at here today is going to be Hip Rafter Systems. We're also going to talk a little bit about Valley Rafter Systems, but I don't have a model for those. So a Hip Rafter System is basically, as you guys have seen in the classroom, is where the end does not come to a gable end like this, where you have that triangle. It slopes down. So you have to end the ridge beam, slope them down, and make that corner that comes down. So we are looking at those dimensions that we need to get off of that. We're going to start out with what is called the conventional case, or a conventional hip, which is what you guys did in the shop. A conventional hip, if you're looking at it from above, this is the common portion of the roof, or the main roof portion, and this over here is the hip roof portion. In the conventional case, they both have the same slope. So if this is a 612 slope, there's a couple different symbols. You might use that symbol for slope, or on a roof like this from above, you might use this for the slope. In fact, they sometimes use this as their slope indicator on a roof. So let's say in this case, both roofs have a 612 slope. Now I'm going to redraw this without so much crap in it. So both roofs have a 612 slope. And let's say we have a span here of 32 feet. First thing we want to find is the length of the common rafter. So the common rafter is out here on the main roof, and the common roof, and it's just the length of one of those rafters. If we're looking at the model here, it is the length from the edge of the roof, or the edge of the wall up to the peak. That sloped rafter length there. So let's see if we can find that. What I'm going to do is I'm going to take a slice out of the house right here, and we're going to take a look at that rafter. So it's going to be 32 feet across. Pretend those slopes are equal. It slopes up to a peak with a 612 slope. So to find the length of that common, there are a couple of things we need to find first. One thing in particular we need to find first, which is the height. Good. And of course we need to find the run of the rafter, which is just going to be half the span. So 16 feet, half of the 32. To find the height, we have a slope of 6 over 12 equals h over 16. So now with just like any other proportion, if we cross multiply and divide, 6 times 16 is 96, divided by 12 is 8. So we have a height here of 8 feet. Now that we have the height, we can find the length of the common rafter here. Note that right now we are ignoring overhangs. So no overhangs at this point. So that length there is going to be the square root of 16 squared plus 8 squared. $17.888 or 17.89 feet we're going to go. That is the length of our common rafter. We're going to save that length. At some point before we are done, we are going to convert that into feet, inches, and sixteenths. But while we are calculating with it, it is easiest to keep it as decimal feet. So for right now, we're just going to highlight that so we can find it quickly later, and we'll be back. Now, if this were the unconventional hip roof where the slopes were different, there would be more work we would have to do now before we get to the next step. For right now, though, since this is conventional, we have the same slopes, we can jump directly to step 2. Step 2 is the length of the main hip jack. The jack rafter, sometimes called the jack master or the jack corner, is this corner here. We can find that later. For right now, we want to find the main hip jack, which is this one here that goes from the peak down the roof that way. So again, looking at the model, that would be, I can get back far enough to get it on camera, from here down on that hip side. Now you can see from the model, that length is very, very close to the length of our common rafter on the main roof. In fact, it is the same. If we are properly framed in a conventional case with equal slopes, that should be exactly the same. So the main hip jack length is going to also be 17.89 feet, just because that's the length of the common rafter. Another piece of information we can throw in here, it's going to be a little bit tough because we're going down to two-dimensional here. The setback. It's not so important on a conventional case as it is on the unconventional case. In the conventional case with the same slopes, the setback is just going to be half the span. So a 32-foot span makes this a 16-foot setback. Notice that's basically just taking half of this common roof there, and that's what your setback is. Everything is the same coming into the intersection there. So once we have the length of the main jack, the next step is to find the length of the second jack, or the length of the next longest jack. That main jack should be the longest jack. So the next longest jack will be the one next to it on either side. Now, its length is going to depend on the slope of the roof, which we've already accounted for, and the spacing. For our purposes, to make it really easy on us, we're going to go 2 feet on center spacing here. So to do that, we're going to look at some triangles. I'll look at this triangle here. It's a right triangle with a right angle right there. We know 2 of the sides of that triangle. We know this one right here because that's our main roof jack, which is the 17.89 feet. But I'm going to argue that we also know this side. How long is that side? 16. So I'm going to redraw that down here. 17.89 feet and 16 feet. This next longest jack then forms another right triangle. At first glance, it doesn't look like we know any of its dimensions, but we do. I'm going to argue that we know this one here. How do we know it? That's 2 feet on center. If this is 2 feet and this whole one was 16, this is now 14, 2 feet less. And this dimension right here is the length of that next longest jack. That is the dimension I am looking for. So we can now set up a proportion. The 16 goes to the 14 in the same way that the 17.89 goes to x. So now we can cross multiply and divide. 14 times 17.89 divided by 16, and I will pull out the calculator for this one. Gives us 15.65 feet. The fourth thing we need to find, step 4. Is to find the jack rafter decrease. The jack rafter decrease is the difference between the main hip jack and the next longest hip jack. Why is that important? Well, let's find it quick and then I'll show you why it's important. So 17.89 minus 15.65. So this will be 2.24 feet. The reason that is important, there's that 2.24 feet difference from here to here in length. Guess what's going to happen when we put in the next jack? Well, the difference from here to here will also be 2.24. That jack rafter decrease is the same from one to the next. So now that we know that decrease, we can go from the longest one, just keep subtracting it and get all of the lengths from there on down. And that's really all we're terribly interested in here. We may be interested in finding the jack corner, or the hip corner, I should say, or the actual hip rafter itself. To find the hip corner, all we're doing is we're looking at this triangle here, and we're finding the hypotenuse, which would just be 16 squared and 17.89 squared for this one. Which will give us 24 feet. So that hip corner is almost, that corner rafter is almost 24 feet exactly. Again, remember, this is not including overhangs of any sort. So now let's go back, and we need to do some feet, inches, and sixteenths. So this here, 17.89, is going to be 12 feet. So I'm just going to type it in how we would do it in the calculator. It's 17.89. So I take, where did I get 12 out of that? Let's kick the little hamster back on the wheel. 17.89 would be how many feet? 17 feet. There we go. So 17 feet. So I'm going to subtract the 17 whole feet. And then what am I going to do with the 0.89? Times, not 16, 12. We've got to make it inches first. So it's 10.68. So I have 10 inches. I'll subtract the 10. And now I have the 0.68 to turn into sixteenths. So times 16 will give me sixteenths. 10.8 or 11 sixteenths of an inch. So that's 17 feet, 10 and 11 sixteenths. I could convert the 15.65, but I really don't care. What I care about more is the jack rafter, the 2.24. So 2.24, I can subtract the 2 because it's 2 whole feet. 2.24 times 12 is 2.88. So that's 2 inches. I subtract the 2 inches, take the 0.88 times 16. 14, so that's 14 sixteenths or 7/8 of an inch. And the hip corner was 24 exactly, so there's nothing to convert there. What do you guys think? Easy stuff? You guys want to try some yourself? See what you can come up with? No? Just want to go home and cry yourselves to sleep for the night? Here's what we're going to do in your packet. Page 282 to 283. 282 to 283 in the packet. Problem number 1, parts A through E. You are going to find for each of those length of the common. Start on the bottom of page 282, yep, where it says review exercise. So you're going to find the length of the common. The length of the hip rafter. You are going to find the longest jack and then the jack rafter decrease. Yes. So there's what? 5 problems there. You need to do that for each of them. Now where it says run of the common, what that is that run of the common is just the span here. So this, I have 32 feet here. So in the first one, it gives you the common rafter length for the first one, so you can use that to find this. You know then the length of the jack rafter, the longest jack rafter, will be the common rafter. For C, D, and E, they give you the slope, so you use that to find the length of the common and go from there. So those are the 4 things you need to find for each of those. Page 282, 283, number 1, A3. Yes, I will.
We just got to read number 1.
Just number 1, the 5 parts of number 1. Fun, right? You got it down so I can hit the recorder now?